Hello, fellow Factorians, and welcome back to my Pyanodons challenge run. This is not an episode. This is going to just be build review and also a little bit of a chat about where things are at, where things are going. I kind of just want to get feedback from my player base, that sort of thing. So let's look at the titanium build first. So I'm going to kind of break this down into the smallest block here and then talk about how the build is set up in general. Let's start with these three machines. The two automated screeners here ingest the ore. They make grade 1 and grade 2 titanium from it. They feed their grade 1 titanium. They feed their grade 2 titanium to this jaw crusher, and this perfectly ratios. The jaw crusher turns the grade 1 into more grade 2. It turns the grade 2 into more grade 1. Yeah, sometimes Pyanodons doesn't approach things linearly. It's like, oh, it's 2 steps forward, 1 step back sort of thing. Anyway, so it makes more grade 1 and turns also outputs some stone. And then all three of these machines feed their results to another automated screener. This screener consumes all the grade 1 from those three, and turns it into grade 3 titanium and some titanium rejects. These two screeners and this jaw crusher kind of form a perfect ratio, 2 to 1. This automated screener will run from these three machines at 83%. So that's close enough. Close enough to make a nice direct insertion combo. The grade 3 titanium is what we're actually going to use as a product, so we take that. But the titanium rejects have to be passed to a secondary crusher. Secondary crusher is going to make more grade 3 and some gravel as a byproduct. If I fed this with just one automated screener, it would not run very fast at all. It would be running about half speed, a little bit less. And this is already running at 83%, so this is pretty bad. So in the build, what I do is I take this group of machines, and then I take these four, kind of flip it around, and now we have two automated screeners creating the rejects and then feeding it straight to the secondary crusher. And then I need even more space. Then what I do is I kind of do that, and that, et cetera, and it kind of makes a nice build. And then I squared it off by like passing the results from one side to another. Like this automated screener doesn't have a jaw crusher next to it, so it passes it over to this jaw crusher over there, and that squares it off and makes a nice kind of direct insertion block. And then, like in previous builds I've showed you, I take all of the stone, turn it into stone bricks right on site. There is a power pole here. That's something I need to fix. The gravel gets turned straight into sand with a jaw crusher next to the train, and I bring in pitch to make the bricks. And Bob's your uncle. That's it. Otherwise, in this build, the only thing that's special is these trains are controlled by check valves. They shouldn't show up if these tanks aren't low yet. So the train will only be showing up when there's a need for it, although the pitch thing had a mistake, so that's why I've got too much pitch. No problem. Let's go over to the copper build now. All right, let's talk about this giant copper build that you can see in its full glory here. Hopefully I'm not scrolling too fast. I would use the cutscene editor to create a nice montage, but I want to talk through it because it's going to be complicated enough. And I think I'm actually going to maybe make a little diagram here. So let's talk about the basic unit. The basic unit starts with these guys. This is our old recipe. These two automated screeners ingest the ore and pass the grade 1 ore into this jaw crusher. All three of them end up making grade 2. The jaw crusher will also produce some byproduct stone. Grade 2 is what we used to furnace just to make copper plate, but now it's a lot more complicated. So, got one basic unit here, one basic unit here. Take that away. The basic unit passes their grade 2 up to these automated screeners. These automated screeners take the grade 2 and move it up to grade 3, and also produce some copper rejects. Grade 3 gets turned into grade 4. Grade 4 is what we want. This is our final product. This is what's going to be sent to a basic oxygen furnace to be turned into molten copper. We also get some low-grade copper rejects out of that. With the prior step, we had these copper rejects. With the copper rejects, we just turn that into more grade 3, which gets turned into grade 4 over here. So we have this little chain of direct insertion there, this little chain of direct insertion here, and we throw out the copper grade 4. With the low-grade copper rejects, we make more grade 4 and some low-grade copper dust. We're going to be throwing all of that out. Now, let's talk about ratios. This is a perfect ratio here. These two automated screeners feed this jaw crusher perfectly. This group of 5, not a perfect ratio. These two automated screeners will actually limit the rate of these to about 95% speed, but that's close enough for government work. Each of this little group here, and this is why I've arranged it into this kind of rhomboid shape. This group, basically perfect ratios. The impact crusher takes the automated screeners copper rejects fast enough. It runs about at 80% speed, and then all these 3 machines will feed copper grade 3 to these automated screeners roughly at the rate that it can consume them. Again, if something's 90% of the way there, I'm calling close enough for proper direct insertion. The one little bit that throws a little bit of a problem into the works is these classifiers. These classifiers are turning the copper rejects from this process into more copper grade 4 and the low grade copper dust. These don't run very fast. I need basically 3 of these automated screeners around them to run this close to full tilt. So that's why I've done this goofy thing in the large build. So if you look closely, like these 3 automated screeners all feed this classifier. These 3 automated screeners all feed this classifier, etc., etc., etc. So by kind of like putting it in opposition like this and having the build on top of each other, you get these classifiers running at pretty close to their full rate. And yeah, this makes a nice direct insertion train. The grade 4, we put it on train, that's going to be going out as a product. The stone, as usual, gets turned into bricks over here with these high-pressure furnaces. The gravel, again, turns into sand. The one fly in the ointment past that is the low-grade copper dust. The low-grade copper dust has to be washed. We get low-grade copper out of that washing process and a lot of tailings, like a lot of tailings. About 1.1 kiloliters per second of tailings. With the, let me see if I can catch it. With the low-grade copper ore, we throw that into a furnace and we get copper plate. That's all we can do with it. We can't turn it into molten copper. So the copper plate is kind of a byproduct of this process that we also want copper with. But this copper has to be consumed. I'll find a way to consume it. Right now, what I was after was the tailings, so I'm okay with this blocking up eventually. Once it's being used for real, copper will be dealt with. Now the tailings. The tailings, I am putting some on a train because there'll be useful things to do with the tailings, but I don't want to be constantly shipping around that much fluid on the train network, even with the long trains. This would fill up in, like, I don't know, 200 seconds or less. So what I do with the tailings is on site, I take a massive amount of tailings, 500 tailings, and turn it into one raw nexellet and 40% of a tailings dust. This compacts it dramatically. So then I will ship the nexellet and the tailings dust off on the smaller trains, and that's just fine. So yeah, we've got this train station to absorb all that with those processes. Some pitch coming in to take the stone and turn it into bricks using the efficient recipe, and the tailings that we save up here. If we've got somewhere to send it off, like that Mark II tree seed thing that I'm doing right now, we send it off, but otherwise all the tailings overflow into these evaporators to be turned into pellet. And that's the build. So let's talk about loaders next. Why are we talking about loaders? Well, loaders unlock somewhere in the middle of logistics technology if you've got that mod installed. The loaders mod is not a core part of Pi, but so many people play with them. There are specific configurations for the AAI loaders, not only with Pi, but they've got them specifically for hard mode. So I thought I'd include them. And I'm not sure that I still am or what I'm going to be doing with them. So that's why we're chatting about them. I was looking at loaders because they'll be unlocking in about 17 technologies from now if I beeline for them. And I wanted to know just how good they are. Like, from the perspective of utility, they're great. They can spit out a full belt of items or take it in for the cost of a tiny, tiny, tiny amount of strip distillates. A little bit of a logistics issue with feeding the strip distillates to them, but they use like zero point 0.1 per minute. If you can see over on the right, they consume that time. And for that, you get something that can insert and extract as fast as 12 inserters, 12 the yellow and red inserters at a hand size of 1, which is all we're going to have over the course of the entire logistics tech tree and halfway into Pi 2. So really great from that perspective, a little bit of a logistics headache from the strip distillates. But I was interested in profiling, like how good from a UPS perspective are they? Are they going to make some of my builds obsolete or, and so I threw together this. This whole block processes 4 lanes of copper ore, just like that copper build that I'd had before, and then uses loaders to load and unload, and then splitters things to filter the products that I need to the different builds. And I was like, okay, how close is this to the inserter build? Which I spent a lot of time working on because of all that direct insertion and lining it up. And I really enjoy that puzzle. So I don't mind the time. It's more like, I just wanted to see, is this competitive? It's really competitive. That's the problem. This runs as fast as that other build where I spent all this time direct insertion. Profile, by the way, you just put together a lot of the same builds, make them all run at once, and compare it so that you can see, what is the UPS like at this rate? And you just put in enough that, the UPS is distinguishable from a version. Like I could put in more to tax my system more, but an update of 2.1, 2.2, I can see the difference between that and something that's like 2.3. So, like a 5% difference is noticeable. And it, more specifically, it overwhelms the overhead from all the scripts that are running, all the other stuff. So you have to have enough there that, compared to the overhead of, just baseline running the game, the difference is noticeable. Yeah, the difference is kind of noticeable. This is runs about the same as my build with a hand size of 3. So when I profiled it, I actually had all the text unlocked, so I was running with the better inserters, with everything having, their maximum hand size, so the inserters were running more efficiently than they really could. When you crank the hand size down to 1, this build that just does everything naively. I threw this thing together very fast, so there's places where, I could get some efficiency by not side loading things. I could get some efficiency by not using as many splitters, etc., etc. I could even use the the loaders with filters on them to do direct insertion. Yeah, this would run better. And that is kind of disheartening to me because, yeah, it takes away the puzzle. If you've played a game like Satisfactory where the default operation is loaders, everything has, is spitting out onto belts and taking directly from belts, that the kind of the inserter puzzle that you get with Factorio is kind of gone. So you don't do anything like these interesting direct loading things. You don't generally do sushi belts in Satisfactory. You don't do a lot of the kind of fun and complicated stuff that you do with Factorio. At the same time, it's kind of good because using loaders, even this is a case where I thought, loaders would not be competitive, but might be close. So it was worth profiling. In cases where I'm just loading onto trains, loaders are so much better. And all those places where I was putting machines right next to the trains to unload direct onto them, I'd never have to do that again because I could put the machine wherever I wanted. The belt, basically doesn't count for UPS purposes. Once it's on a belt, as long as the belt is shorter than 100 tiles, it doesn't matter if it's 1 tile or 100 tiles, it's the same UPS cost. So it would get rid of all of that puzzling stuff, which is, for me, kind of like, I was enjoying direct loading straight from machines onto trains as kind of an interesting strategy to save some UPS, but would also mean like my train stations are less of a headache to build, put together. I don't know. Anyway, so my concern that I'm tossing to you guys: should I continue using loaders? Because I want to use every tool that I've got available in my toolbox. I just may adjust what's in my toolbox because if I had them, I would definitely use them. On the other hand, if I'm not using them, I may not end up hitting my UPS targets for my next stage, and even further down the road, these are going to speed things up. I would still do something with biocranes. So biocranes are a feature that's kind of in game. Are they here? Oop, I typed in the wrong thing. Biocranes. Nope, I can't type. Biocranes. Biocrane is one example of an inserter crane. There's other mods that do inserter cranes. I might actually install a mod to them because they're only kind of in the game. Look how ugly this graphic is. It's clearly a beta gray box graphic. It's not a final graphic, or at least I hope so. But what inserter cranes do, they have like a massive hand size. In this case, the hand size is 150. They load slowly. The biocranes are hideously expensive in terms of both the ingredients cost and the fact that even idling, they take 500 kilowatts to just sit there, and 1.2 megawatts to when they're working. But you can move a lot of items with a biocrane. In fact, like if you're just doing a box to box transfer, like I'm doing with this loader, biocrane is actually faster than a loader in terms of UPS. So I might get something out of that. I might get something out of using stack inserters, which have large hand sizes, or bulk inserters, which have large hand sizes. These, still offer me a little bit of room to play around and maybe get some efficiency on top of loaders. Because I'd be concerned that if loaders are really the best end all be all of all technologies to save UPS on loading stuff, that a lot of my builds end up, doing a prettier version of this. Like, again, if you played Satisfactory, you have a manifold that feeds the machines. You spit everything out onto a belt from that manifold. You put it into a different manifold. You put the machines, take that stuff out, etc., 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 and you get kind of builds that may not look that interesting because they're just a line of machines taking out a manifold, spitting onto a belt that turns into another manifold, etc., etc. I'm not sure it's going to end up like that. Like, loaders do have a little bit of, like puzzling in the sense that you have to feed them a liquid like this. Although they do feed through. So, like, if you have a line of loaders all in a row, they would feed through each other. I feel like I'm babbling at this point, but I hopefully have conveyed the concern because I want to keep doing interesting builds. I enjoy them. Hopefully, you enjoy looking at them. I may end up using loaders for just, like what they're designated for, which is loading. I may end up deciding, like I'll install a different inserter crane mod, or I may install a mod that takes these bulk inserters, which will unlock at some point, or the stack inserters, which will unlock at some point in logistics. I think both of them are. Let's check. I'm not sure about the bulk inserters. No, those are in Pi 2, but strangely, the stack inserters are in logistics level. Let me find them. They're kind of weird to find. I think they're here. No, they're here with stacking. But yeah, still within logistics science. So you get them. The weird part about them and the bulk inserters, there's no long version of them. These are 1x2, so they're kind of long, but they won't do what a long inserter does, and which gives you more options for that puzzle where they can skip over a tile. So you can skip over a belt, or just use them to, if you want to have a machine that's 5 tiles away, stuff like that. So I could install mods that give me the option to stretch these inserters longer. I don't think I want to install Bob's adjustable inserters, which is like the most powerful version, which lets you do like crazy stuff. Like, I'm going to take from this chest right here and put it in a chest right there, or a chest that's over here. Yeah, Bob's adjustable inserters just makes everything too crazy. But what I might do is, install a mod that lets me do with every inserter, turn it into a long inserter, or even like an extra long inserter that's like 3 tiles wide. I'm not sure. Again, I would love to hear your feedback on this because I want to keep moving forward. I want to keep building efficient builds, but I want to be challenged to do this in an interesting puzzle rather than a layout of pure manifolds. I also will want to end up testing, like what happens if I do kind of like direct insertion, but with loaders. It does mean that the puzzle goes away a little bit more, but is still kind of present because, you know, there's no challenge at all to like the belt can be like this and that and the other thing. And yeah, you're direct loading from one machine to the other, but the machines could be like 100 tiles apart. It's just you're getting the efficiency of only one machine talking to another machine through a belt, which you were getting out of having one inserter talking to another machine. So it skips loading it onto a belt at all. But because of the inherent inefficiencies that are somehow built with an inserter, that's still slower than using loaders. So let me know what you think. I'll be doing more episodes. I will probably be doing something where I try and do builds that don't really rely. They're not about the inserter capacity or like the direct loading. So I might kind of do a bunch of builds that depend on making seaweed, and seaweed runs so slowly that it doesn't matter if the inserter costs much UPS. Although I did like profile a build that uses loaders and inserters, and the loader build was actually still better for seaweed. Just like taking something the seaweed out of the machine, putting it onto a belt was better because I guess loaders are faster because they have less bits and bobs to them than an inserter. Okay, I've rambled enough. um Give me some comments if you end up watching this episode. See you next time.